Great. So the workshop tonight is on Git, which is a version control system, and GitHub, which is a code sharing platform. The goal of this workshop is to give you a really solid foundation on how these work so you can go on to become an expert in the future. And at any time, feel free to stop and ask me questions if you don't understand something. You also can put it in the workshop text. So the first thing is that Git and GitHub are two separate things. GitHub is a code sharing platform, which is built on top of Git, but Git is a version control system, which is hosted by a whole variety of websites. Like there's also GitLab or Bitbucket, and you can also just put it on your own computer. And I'm gonna go through Git first, and then I'll talk more about GitHub. So, why version control? Well, the first most obvious thing is that it takes many backups of your code, and you have a whole history of snapshots that you can choose from. And for this reason, like I actually put my homework in Git, even though I'm working on it by myself. I can put it in a private repository, and that way I never lose anything. Another reason is for experimentation. You could create another branch of your code and do something that's new and different or maybe a little bit risky, and you can always go back to the other state of your code. And finally, which is where GitHub comes in to a large extent, is collaboration. It makes it really easy to work with other people on a large project, and people can work on different parts of the code and bring it back together in a logical way. So, first of all, repository. A repository, which I have a little sample of a history of snapshots of a sample small repository, this is just the history of snapshots you've created. But a repository is basically snapshots of your code. And if you've used things even Google Docs has a history of versions of your code where you can go back. And so you've probably used a lot of different software that does that. So what makes Git different than something like Google Docs, though, is that you decide when you want to make snapshots of your code. And you decide what you want to make snapshots of. So you have a lot of control. And you can think about that, how that's very essential, because you don't necessarily want to take a snapshot when you're in the middle of a line. You don't want a whole bunch of snapshots that don't compile or don't run. So memorizing 6 Git commands, a practical guide. So this is one approach to learning Git, is that you just memorize these 6 commands and maybe a couple more, and you do them. But so I will go over these commands, and after I go through my slides, we can do a little demo where we can follow along and use commands if you like. And I can tell you the basic idea behind them, git clone is to copy from GitHub, basically, a repository. Add and commit is how you make your own snapshot. Push and pull is syncing with the remote repository. But the problem with just learning these commands is that Git is infamous for having a very steep learning curve. And if you don't understand the basics behind it, it's very easy to get into trouble. If you understand the logic behind how all these commands work. So here's an XKCD comic on this very problem, which introduces Git. So this is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool. How do we use it? No idea. Just memorize these shell commands and type them to sync up. If you get errors, save your work elsewhere, delete the project, and download a fresh copy. So this is something that a lot of people who've worked on Git have probably done, because there's a lot of advanced commands. And I think the best defense against getting yourself in a situation where you feel like you just have to start over or you just don't know what happened is to really have a solid understanding of the fundamentals. So everyone will say you need to use Git, but then sometimes people will argue, oh, it's so much work. You can get into trouble. It actually had deleted my code one time. So what is the truth? All right, so Git is actually an incredibly powerful tool. It's very versatile, it's very flexible, and it's also very abstract. So it can be used in a number of different ways. But with all that abstraction and with all that power comes a lot of complexity. And there's no built-in UI. People build a lot of UIs on top of it. And there's no one standard workflow in terms of how to use Git. So you need to learn about some of these things and make some decisions for yourself about how you want to use it. And that makes it, and that's okay. Like, it's good that you could have a different workflow if you're working by yourself or if you're working with a certain team, like a big, large team. Those have different requirements. But so the thing that you have to understand about Git is there's no guardrails. You know, there's no bumpers in the gutter. You can do a lot of different stuff. So that's why I kind of want to focus on what are the mental models behind Git that will allow you to get yourself out of a situation when you're not and understand what all the commands are doing and also what advanced commands are doing. All right. So this is the first model you need to understand. And that is that Git is a distributed version control system, which means that when you copy a repository, when you say git clone and put a repository on your own computer, you have a full copy of that repository. You have all of the history. In this particular graph, here we have this GitHub, the Git Octocat Ninja representing GitHub. And so maybe there's a repository on there, but everyone pulls it onto their own computer. So these 3 different developers on 3 different laptops could have that repository. And then the working copy is referring to the changes you make to your own files. And then you commit them to the repository, and then you sync them up with the remote repository. But it doesn't, like, you could even make another copy of the repository on your own computer. So the biggest thing to understand here is that those are the same, fundamentally the same thing. The repository on your computer and the repository in GitHub are the same idea. So does everyone understand that so far? Have any questions? All right, so very simple to create your first, like a basic repository on your computer. You can always sync it up with GitHub later. It's not difficult to do. In this example, I have this directory on my computer that has 2 files on it. And all I do is to make this directory a Git repository is I type git init. This is in my terminal on my Mac. And then, as you can see by this master in my prompt command, I now have a repository. And when I list the files, I listed the hidden files too here. There's now this .git, which is a directory, and that is basically your repository. It has a whole bunch of internals in there. You can open it up and look inside, but you don't need to. You interact with it through the commands. You should just know that it's there. All right, and then to make your first commit, when you do that, you've created a repository, but you haven't added anything to it. It's completely empty. Even though you have those files in the directory, you have to actually add them to the repository that you've created. So in this case, what I did was git add dot, which adds all the files in that directory. And then I committed, and I called it an initial commit, which is sort of standard for your first commit. And then you see here it says 2 files were changed and 2 insertions, which means just because there was like 1 line in each file. So if I had done this and there had been 200 files, it would still have added all 200 files. So, yes. So, yes, I do. It is saying that all files that have been modified, you're adding them all at once. You're not worried about if they're going to be in staging or not. So I have a habit of doing this sometimes to commit everything at once. But I'm going to talk to you now about why that might be a bad idea. So get out all the files. You can add them all to staging. You can commit everything that's being tracked, but James, did I answer your question? Does that make sense, what I said so far? Okay. But you're really not, why is there the staging area? Like, why do we add files into the staging area or take them out before we commit? You're not really making use of that staging area. So can anyone think of a reason why you wouldn't want to add and commit everything in your directory at once, like every change that's been made in your directory? Can you think of any other reasons? What if we made changes to experiment 1 and then also experiment 4, and those are just totally unrelated experiments? So that's okay. So this is a good question. Let's continue. This is the big question: is when to commit and what to commit. So you should commit after each logical change, right? And so you need to think about when is a commit too big, when is a commit too small, right? So you don't want to make a commit after every single line that you change, but you don't necessarily want to create like you don't want to make a commit for like every change you made in your project in the last 4 hours, no matter what it was, right? And I'm talking about time scale here, but that also relates to different parts of your project. You might want to have commits organized by, okay, well, I was working on this part of the project, and so this commit bundles up these related changes, and then another commit will bundle up some other related changes. So here's an example. If you have your working directory and you say you changed a bunch of stuff to the login, like say you added email validation, but then at the same time you also like added a form to the footer, and that has nothing to do with login. And so you could add login.js and login CSS to your staging area. And now they're sort of in the staging area and ready to be put into your repository. And then you can just say git commit and put what's in your staging area into your repository. Whereas maybe there's another folder like footer.js where you just leave that and you make another commit for that. And one of the reasons for that is, okay, so later on, you notice that there's a bug in login, and you see that there's this commit that's like, oh, added email validation for login. Well, it's not working the way we expected it to. So that might be the right commit to look at. If you made a whole bunch of different changes, like think about not just these two, but you made something to footer, you made something to like some other page and to the header, and then like it all. And if you think about it too as like a more robust program, like a game that has different features in it, the history is not going to be as valuable to you if everything is all tangled up together. So this is one way you can use a staging area. Does that make sense? But so the great thing about that is that everyone's been using Git wrong. And so we all just learn as we go and trying to get these fundamentals ironed out. Yeah. And here's the thing, like if I'm working on a homework assignment, I'm not going to be like obsessive about making everything, committed exactly right. But if you're working on a big project where someone else might need to figure out what you did in your code, then you might want to be more organized, So it really depends on the situation, how much work you put into keeping it clean, but by default, you should try to keep it somewhat organized. So, all right. So another way you can keep your code organized is through branching. You can create different branches for different features and for different bug fixes. So in this example, maybe one developer is working on the purple feature and another developer is working on this green feature over here. And every single branch has a different name, and you can check them out by that name. So you could say checkout master, or I don't think they can have spaces in them, but anyways, this is sort of an example, not the example of the branch names. Okay, but so how does Git, I think the most fundamental thing, like we've talked about it being distributed, we talked about being a staging area. The third big concept I really want to stick in people's minds is how Git actually thinks about the repository history. And that is represented by this slide. So your repository history, which you look at as like a list of commits, is actually a directed acyclic graph. And so here's an example. I put like this one screenshot here of what the actual like commit message looks like. And so like that's all the data for a certain snapshot. But in this slide here, I have 4 snapshots, right? So the first one was my initial commit, and it has this commit number to it. And here I'm showing a shortened version of it, which is like 7 digits, but really it's like really long, like 40 digits or something. And what that actually is it's if you take your code and you take your metadata with that commit and you run it through a hash function, it creates a number ID. It's basically a hash number. And so that makes every snapshot have its own unique ID that it can be referred to. And then all these have the name of the person who committed it, and then the date and the message. So
I can't hear.
Oh, I'm sorry. Can you hear me better now?
Carolyn, I'm so sorry. I didn't realize I wasn't on mute.
What? Okay. Oh, sorry. I got it. He was talking to someone else. Okay, so as you can see here, I put in red a different commit ID for each of these snapshots. And this is the shortened version of the commit. You can just refer to like the first 7 characters. You don't need to refer to the whole long commit ID. And here's an example of where there's like a feature has been added to the master branch, but then this bug fix branch, which actually points to an earlier point of an earlier commit in the master branch, is a new branch, right? And so each of these branches has a name. One's the master, one's the bug fix, and you can check out things by their branch name, which would be bug fix in this case, or master, or you can check out things by their commit ID. So one of the things I want you to get from the slide is that if I'm on the bug fix branch, it knows these other 2 snapshots as its history. And it doesn't know about the master branch in terms of its history because it only has a reference to its parent, right? But then we can merge them. So if you just run this command that's git merge, if you're on the master branch, right? And I'll show this in the demo later on. I want you to understand the concepts, not necessarily the commands that you write. But you can say, okay, merge in the bug fix branch. And now you have the code from that feature and the bug fix all together. And this always works perfectly, and you never need to worry about it, obviously. So does everyone understand what I'm trying to show in this graph? Do you have any questions about this graph? Those are the best kind. Okay, so check it. So you can think about, especially with this one, the most recent snapshot in time, well, actually in both of them, but is this one, see how I have time on the bottom and now is it to the right? So here you can actually check out earlier snapshots. So you can say, check out 3692423, and you can get the version of the code that doesn't have that bug fix, but has the feature, right? Well, the other thing you can do is check out as how you go between branches, because it won't show up in your history, but if you're on the master branch, you say git checkout bug fix, and now you're suddenly on this bug fix branch, which means, yes. How about everyone else? Like, and do people know what I mean by when I say a directed acyclic graph? Has everyone taken data structures?
Not there yet.
Okay, so I will go one by one. So a graph is just, you have some sort of data represented by nodes and links between these nodes. In this case, the nodes are these circles, which are the snapshots of your code. Literally just a snapshot is just where that code was at that point in time.
Mm-hmm.
And then the links in this case are the fact that there's a link to the previous commit in history, right? Now, it's directed because this most recent commit knows about the commit before, and that one knows about the commit before that. But the commits, you can't, can you see my cursor?
Yes, your cursor is showing. Yep.
Okay, wonderful, thank you. But this commit here, where you're on this feature, doesn't know about this one. Like, it's just a reference to the past. So you can get back here by saying like checkout master, but it won't show in your Git log when you look at it. And the reason it's cyclical is that it's only pointing to the past. It's never going to point to the future. And so a cyclical graph is something where you could go backwards and then forwards, making a cycle. But this is just always going to be in one direction. You can't have any cycles in this graph.
Got you. Thank you.
You're welcome. Any more questions on this? Because I think if there's one thing that you understand from this workshop, I think this slide is the thing to understand, honestly. And we can only go over the tip of the iceberg in some ways, but if you understand these fundamentals, when you try to use some more fancy commands, then you'll have some idea of what they're doing and you won't get so lost. You know, you can understand the explanation between, because there's a lot of Git commands. It's not just 6. But you can, on a daily basis, get away with very few that are worth memorizing. All right, I just want to give one more minute. Any more questions about this? All right, we can always go back. Oh, I was going to say this. So I did tell you that you could check out a previous snapshot, right? So you could check out this 3692423 or an earlier one. But when you do, you get this funny message, git checkout, you are in detached head state. So what does that mean? That means that all those branches, when you say master branch or bug fix or feature, those point to the tip of that branch, which is the most recent commit. But if you're in detached head state, you're not at the head of that branch, you're at some previous commit. And that's important for you to know because you don't want to lose that future information. When you say git log, it's not going to tell you about that future information. It's not just going to tell you about the previous stuff. So if you need to use this previous command, there's a few things you can do, like you can create another branch and then try merging it later. But this is just one of the many funny errors you'll get that I wanted you to know about and understand. And this is not really an error; it's more of a message letting you know that you're not the most recent placing. All right, so. Mm-hmm. No. No. So what it will do is, I think if you, maybe it will make a new branch. I don't know. Let's try it when we do the demo. I think that it might complain to you, or let's try it. I'm not actually sure off the top of my head. All right. So a minute ago, I told you that it will merge it for you, right? If you merge one branch to another, you have a bug fix, you have a feature, and that all works perfectly. So just a quick question. Did you believe me? Git really can do a lot to merge things automatically. It can, if you are working in different files, no problem. It'll put this file over here, that file. If you're working in different parts of the files, it will It will add what lines, like if James added some lines and I deleted another part of the file, it will just put them together and hopefully that's okay. But if James made some changes and then I made a branch and I changed some stuff in that branch and then I tried to merge back into the original branch, it'll just take my changes. It doesn't care what I overrode them basically. But if James makes a branch and I make a different branch and we change the same line, then when you merge, what does the program doesn't know what to do. It doesn't know who to trust. So Git merge sometimes looks more like this, where it's a little bit more complicated. This is called a merge conflict. When it doesn't know what to do with the code, and so it leaves both of them in, and it tells you that it's left it in. So here's an example. What Git will actually do, which can be alarming if you're not used to using Git, is in your code, it will add these giant arrows and say, okay, here's these two lines. You need to choose, right? And so here it's telling you that this message here, this green message send, was from the head, and then blue message was from a merged branch. Now, one configuration I will recommend is to set it up to use diff3 style because it gives it a little bit more information. I took this example from a blog post, which I linked to at the end, and also on GitHub. But the nice thing about this is when you looked at this original thing, the question, you might wonder, what was the original problem here? Because it says green message, and then if you look at the end here, it says true, and then it's blue message, false. So what was the original thing that someone was trying to fix? And here you can see that the actual thing that both people changed was something that said blue message.true. So maybe we want to keep both of these lines because these two people fixed this bug in two different ways, And again, to keep them, you would delete this middle part because that's the old thing. You would delete these arrows and the messages and then just keep the lines of code. All right, so I'm going to give you a few tips on how to configure Git to make it easier to use. I have them on GitHub right now that you can follow the instructions and we can help during the demo part. And so the first one I recommend is something you put in your bash profile to autocomplete commands. If you use the command line, you might be familiar with hitting tab to commit a command line to either autocomplete a command or a file in the directory. Now, Git doesn't have that by default, and it's very useful. Another one is to put some information about Git in your command prompt so that you can see what branch you're on, if there's files that need to be staged, just like at a glance. And the third one is to set up diff3 for the reason I just went over. But this is my basic pitch on how Git works. And we can go over our specific commands in the demo, but does anyone have questions about this? Did this make sense to people? I'm going to go on and talk about GitHub next. Okay, you can also put questions in the chat if you would like. I don't know, maybe there's a raucous conversation going on there because I can't see. But GitHub. So GitHub is where you can host your code and share it with the world. You can see other people's code. There's a whole bunch of open source projects on Git that are just waiting to be forked and changed. And it's also something a lot of employers look for is a GitHub profile. It's just the most used and popular platform of that kind to show off your work. So the most important thing with GitHub is to just get started. Like if you don't have a profile already, go ahead and make one today. You don't need to have an impressive project to put on it. You can have a little project. You can make up a demo product to practice how it works. It's not a big deal to get started, but getting started will get you on the path to putting more and more stuff on it. So you want to add a profile pic, make your first repository. You can just play around with the text file if you want. You can fork a repository. And one tip is to add a custom profile. So create a repository named your username on Git. So like mine is Carolyn K. And if you make a repository with that same name, my repository is called Carolyn K, the README file will now be your new profile. And you can include emojis and headers and stats, and it looks a lot nicer. And one cool thing that you can add to that profile is stats cards, like this one. You can go to this link and get your own stats cards. And some of these will be, it's fine if some of these are 0 to start out with. It gives you goals to put more stuff on. And you don't, it gives you an A or an A+ even if you don't have much. It's very kind that way. But this is like a cool little thing to jazz up your profile. And then go ahead and fork some code. Here's an example of Tensorflow, which is an open source project that you can build a machine learning model with. And you can go on there and you can fork it and just follow the tutorial to make your own machine learning model. If you look at the code, this one or some other project, they'll have a license, so it'll tell you what you're allowed to do with it. This one is available for commercial use and modification, distribution. So there's a lot you can do with this. And then contribute. Go find an open source project. You can look for the tag good first issue. Some of these are, minor documentation issues or a very small bug fix or a new feature that you might be able to implement. And then after you've made your changes, you can fork the repository. You pull it down to your own computer. You make your changes, and then you do this thing called a pull request, which is asking the owner of the code to accept your new code. So here's an example of an issue. This is a very simple issue that's asking people to add resources for React resources. So you can go and find very straightforward issues like this. And the important thing is just to get started, get used to the process. There's also this thing called a Hacktoberfest going on right now that there's a lot of people making super simple first issues. Some things are just asking you to add your name or add a meme or something, so that you learn how to commit to a project. But this is the workflow that I was sort of describing before. The master branch is owned by the project owner. You fork the whole thing, and then you make a branch from master. You commit your changes, and then you submit this pull request. And then there's this process where other people on the project, maybe the owner or other people, can make comments on what you've done. And they might say, oh, this is a great new feature, but we need it to be in red, not in blue. And then you make those changes, and then they eventually accept it and put it in their own project. Another thing is to get the student developer pack. You can get free GitHub Pro, which means you can have private repositories for unlimited contributors. There's also a whole bunch of other software deals and tools because they want to get students to get used to certain tools so that when they do get a job, they can pitch it to their company, or when they have a budget finally and a job, then they'll get the money. But there's a lot of great things you can learn to use, a lot of powerful things you can do for free now. And finally, and most importantly, is to join our GitHub, the IEEE Student Branch. The slides and the information about this workshop will be on here after tonight, and you can have previous workshops you can see. So, does anyone have questions about GitHub before we try to go and actually make a repository? Mm-hmm. Mm-hmm. I know, it's so weird. It's kind of like what it really is it's asking them to pull from you, I think is why it's like that. I know. That's what I think. Why they? Sorry. I know. I have the same problem. All right. Let's see if I can show you my terminal. See my terminal? Yeah, I'll fix it. Oh no. If you want to follow along, try to do a few commands and understand how it relates to what I just explained. If you actually go to I have this up on Git right now. I'm posting it into Workshop. There's a link here to installing Git on your machine if you don't have it. It's really simple. On Mac, you use a homebrew command, and if you don't have homebrew, you should just go ahead and install that too. But
on Windows, it's even easier. You just download the exe from the Git website. I'll link that right now.
Oh, I mean, I put the install thing there. I think it's the same. But so.
Oh, you already put it?
I think so. So do people, would people like to follow along with some basic Git commands? And if so, let me know if you have a folder set up, if you have Git installed, or if you are trying to install it.
Yeah, let us know if you run into any issues. Just put it in either Workshop or Helper one text.
Or if you have questions up to this point, feel free anytime.
Can I just use any folder?
Yeah, so just make a new folder and start there, I would say. So if you're in the command line, you can make a new folder by doing this. In a new folder. And there's nothing in this folder right now. Oops. Can't not do that. Okay, so you see this is.
Should I know how to do that too?
Are you, what system are you on?
Windows.
Yeah,
Okay.
on Windows, you're not able to do ls. I would recommend if you can get, if you can grab the Linux subsystem for Windows really quick, it'll be the exact same commands that she's using.
What about, do you have something to connect with like the pool servers? If you're on any Linux server at all?
I don't think I am.
Oh, Rob, people are saying download Git Bash.
Download Git Bash, is that a thing?
Yes, you can do that on Windows, and you can use all the Unix commands.
Okay, yeah. I just use the Linux subsystem, or msys2, which gives me all the Linux commands on Windows. But there's a lot of options to be able to use the Unix commands and Linux commands on Windows. So,
Okay, yeah, I get that.
Excellent.
And Unix and Linux, or Linux is used on a variety of servers, so it's not only built into Mac, it's a good thing to know how to do Linux commands.
Superior.
True. So I think people are trying to install it. So I think I might wait a minute. Is that the case?
Yeah, while people install it, you want me to give a quick rundown of what a GitHub commit, or like a GitHub merge thread looks like? I can share my screen and show the merge process, when you commit to merge something and then people make edits and everything, the discussion process and everything.
Yeah, that's
you
great.
show that off?
So,
okay.
Yeah, why don't
so
you...
while people, this isn't important for everyone to see, but if you have it all set up already, I'll share my screen real quick, and I'll just show off really fast what a Git merge looks like. So
you can just hit live on James to see what he's doing.
yeah, so I'm gonna head over to GitHub for a second. I'm gonna show you a really simple commit thread that a pull request that I submitted to a project called Shrine, which is a Temple OS distro. You can actually see I'm listed down here as one of the contributors because I made a contribution. This is another great thing. If you make a contribution, even if it's a really small contribution to a large repository like this one that has like 800 plus stars, you get listed as a contributor. So I'm going to go into the pull requests real quick, and since mine got added, I'm going to go down into this this one right here. So my commit was really simple. So I forked it, and then all I did was I added one line in the Git attributes to make it so instead of listing all of his code as C and C++ based, it instead lists it as the appropriate programming language, which is wholly C. So basically you can see that I said, oh, I couldn't help but notice that Linguist incorrectly classifies most of this repository as being C and C++ code. So I've made this commit to fix this basically. So, and then you can see this is in my own personal branch after I made this change. It now displays it as being primarily in wholly C. So you see these threads basically, you have people saying, oh, I've done this. And then you also can see, oh, this is like what they've actually committed. And if you actually click on this, it shows exactly what I've added. It shows the previous branch, which there's nothing because I basically created this. And I added this one line to a new file. And then the creator saw this and said, oh, that's a good fix. And then it merged it into master, which is why I am now a contributor of this repository, even though I've only added one line. But let's take a look at, I personally haven't made any super big merge requests, but I do know there's people who have, so I'm going to go take a look at someone I follow who's made a lot more merge requests. I'm going to take a look at, if I can find him, Matt Godbolt real quick, because he makes like actual contributions to massive repositories, if I can find it. Here he is, right at the very bottom. So let's take a look at some of his pull requests. So he's committed to Compiler Explorer. Let's take a look at some of like the real pull request threads that people add. Let's see, I should probably look at closed ones. So, okay, you see that people will try and submit like these fixes on random things, compile CUDA with multiple versions of Clang. So you'll see that it starts out, someone basically says, okay, this is what I've added, and then they'll add reviews and whatnot. That's what these little things are here. This thing, the little book with the arrow, it's when you do a force push, which I don't think we should get into that. But you can see they add commits, and as it goes on, as people give feedback, you can add more and more commits to your branch that you want to merge in. And then finally, at the end, you can basically, this commit at the moment, it's in review, which means people are going to look it over before it gets pulled to the real code base, essentially. And if we look at closed ones, we can see ones where the review is already done. I'm going to try and go for one with lots of comments, because that's normally ones where there's a lot more discussion about what's going on. So you can request reviews on code from code owners, basically. So you can see this person said, okay, I've made this edit. I'm requesting a review from the owner. And then this little arrow means that someone mentioned your issue in another discussion, which is very useful to see because people are constantly mentioning issues that people open on GitHub for other projects. You can see people will then request. So this is when a code editor basically looks at the review and says, this is some things that needs to be fixed. So they've requested these changes within this branch before it's fixed. And then this person says, oh, okay, so I'm going to, commit that. So then they go and they fix these changes and add them in right here, you see. And there's a bit more discussion. And then finally, they request a new review. And then at last, once everyone's happy with it, then the code owner merges it in. And then you can even discuss changes afterwards. But normally, after the merge, you basically just say, oh, thank you, or delete the branch with the merges since it's been merged back into the real branch. So that's just a quick example of what a Git, when you're making a pull request, what it generally looks like. People will tell you, oh, you need to fix these changes before we merge this. And yeah, that's just a quick review. So by now, I hope everyone has installed Git because we're going to hand it back to Carolyn, and she's going to give some basic examples of how to do Git from command line. All right.
All right. I have 4 people in my live. 9 people.
Everyone go rejoin Carolyn's stream.
How many people did you have in your stream, James?
That's a good question. I think I had like 10.
All right.
I assume
We've
they
got
were all
13
gone.
now. I think
Okay,
we're
that's everyone.
probably
Yeah,
good.
we're good.
All right. So I have this totally empty repository, this totally empty folder, and I'm going to create a file. I'm just going to do it a simple command line way, saying touch hello.txt. I'm going to make it as simple as possible because I want to talk about what Git's doing and not worried about what's in the file. And then I have this set up so that if I can open a file with Sublime. You can open it with the text editor of your choice though. So if I don't know how this works on Windows, but if you go to this directory, even in just Finder, you can go and open the file, or you can say open hello.txt and see what it opens in. It might open a notepad or something.
Yeah, normally we would use, you could literally just type notepad and then file name, and it would open it. At least I'm pretty sure that's how that works. I personally use code, which opens VS Code on the file.
Correct.
Yeah, it works that way.
And you can set it up to do VS Code or Sublime tests within Git too. There's I have instructions for how to do that in GitHub. So if you're doing a merge, if you're doing a commit or a merge conflict, you don't have to use Vim. You can use whatever you want. Okay, so here's this file. It's making it hello world. And so now I have just this file in here. And then you can say git init, and if you have git installed, I like to backspace to reuse commands. You can see I have a file and I have the Git repository. If you just list it without using that A flag, it'll just show the file because the Git directory is hidden. But that's where all the secret sauce is of your repository. So, what do I want to do? Git status. You can type git status and see what the status of your repository is. We're on branch master. It says it in my command prompt because I set that up. But then when you type git status, it tells you what branch you're on. We have no commits yet, and we have this one untracked file. So I know I'm going very slow, but is everyone at this point? I don't know if people are brand new or like I know a lot of you have used Git before, and this is very slow, but do people understand what's going on so far?
Yeah.
All right, so now I'm going to say git add, and I'm actually going to say dot because I just have this one file and I want to put it in staging. So, and now if we look at status, this file is now in our staging area that we talked about before. So now we can just say git commit. Oh, it wants me to give a message because I didn't give it the message flag. So I'm going to say this is the initial commit. And I'm just going to save that. I realized, is everyone okay with making that initial commit message? Is anyone stuck in Vim right now?
What's the dot for? I mean, I just did git add and then said, did you mean git dot?
So I said git add dot because I just wanted to tell it to add everything in the current directory. And in the command line, the current dot refers to the current directory.
Gotcha.
Yes, and then dot refers to the directory above the current directory. That's common Linux, Unix terminology. Dot refers to the name of the current directory.
So you can see if I do pwd, that's print working directory, shows me where I am. If I say cd ... and I do print working directory again, it shows me I'm one file up. So I'm going to go back to this. All right, so we do. So now we have git, we can say git log. We can see our initial commit. And the other thing you can do is say git log, one line, to see, oh, I spelled one line wrong, to see a compact version. Right now we only have one, but if you have a whole list of them, great. So is everyone to this point? Any questions? I'm going to change my file now. Oh, can you see, you can't see my text file.
Now you're sharing window instead of screen.
I thought it would be easier because it would show it full screen, but it was change windows, screens. Here we go. So now we have infinite screens here.
Oh, Matt is stuck in Vim.
Yeah, okay, so let's take a step back. Okay, so first of all, to get out of Vim, type your command. Well, first you have to say, I guess, A or I in order to be able to type. Are you able to type your commit message, initial commit?
I'm able to type in here, but
So then after you do that, you say escape, and then do shift : WQ exclamation point. Try that. Is James helping you in the chat?
Robin's helping him.
Okay. Thank you, Robin. So let's configure our editors to be better. Choose an editor. Here I have something for this. For mine it was Sublime, but I think here's a whole doc on it. I'm gonna post this into the chat. Okay, so yes, I always force quit. You can use Atom, you can use code, which is code -- wait in here. This is what James was talking about. Sublime or TextMate. So these are the basic ones that are good ones to use. If you have any of those on your computer, I recommend just copy this line that says git config. And if I did this now, it would start opening my stuff in Virtual Studio Code. All right, I'll let you continue to work on that, but you can see my file now, right? So I'm going to make changes to this file. I'm going to say hello IEEE, and not LS. I want to say that was a long journey. So I'm going to say git add. Well, actually, message. I'm going to say this is a fix, and I'm going to say greet IEEE. I don't care about the whole world. Oh, it wasn't staged. So we can say git add, we can use that dot again, or we could say hello.txt. If you go to status, you can see that this is now, it's green, this green message here. It shows that it's in your staging area. So now I can do this commit message again. And you see, last time I said git commit and it opened up a text editor of your choice. You can also just say -m, and that will prevent you from going into Vim. You can just put your message right in this command. All right, so we have another commit, one line. All right, so here's another command called git branch. And you can see all your branches. We don't have any yet, but we can say git branch, I'm going to call it comp sci. So does anyone have any questions on what I'm doing to this point? So now I'm going to check out my new branch. Comp sci. Boom. And if I say git branch again, I'm using the up and down arrows to get previous commands. So I'm here, it shows me the last command before that, just a shortcut, so I don't feel like typing. So now we can see that we're in the comp sci branch. And also in my prompt, in my command prompt, it says it, because I set it up that way. So now, I will change this file, say, hello, computer science students. Great. Fix great comp sci students. So you notice here what I did? I just bypassed the staging area. I said everything that's been changed, just commit it, because I've done so little. But it is important to know that you always have to add something if you create a new file, but also it's important to know that you have the staging area to organize things in. So let's look at the log now. So now our branch took off from this commit in the master branch. That was the last thing. And so now we have 3 commits and we're on the comp side branch. So if I say cd, git checkout master. So now we're back on master. I didn't change the message. So now watch what happens when I click on this file. Oh my gosh, my work disappeared. So right now, Git is like in that directed graph that I showed you. Git is saving different versions of your code. So it's possible, something that happens to people with Git when they start using it is that they make some branch and they do a bunch of changes, and then if you switch, you might be confused about why your code changed. So does this make sense to everyone? What's going on so far? Have any questions?
We're having a few issues in the chat, but I think me and Robin are handling it pretty well.
I'm just gonna look. Yes, it's AM. The M flag is for message. Oh yeah, so press maybe escape or command.
Control C always
Control
works.
C, yes. Just hit stuff until it works. Okay, so are people following along with this? Okay, so Git branch. I want to see what's going on. All right, so now I'm going to merge the new the comp sci in, and so I'm going to say git merge comp sci, and it says okay. Fast forward. That's interesting. It also says we've changed this file, we've made an insertion, we made a deletion, and now if we look at the current state of our code, it has this computer science students again. We've overwritten what was in our master branch. And the reason that it overwrote it is if you look at git log, you can see that the previous commit was the IEEE. There wasn't a future commit after that. If I had made a new commit after that, then that would be a different story. So let's try this. Let's say git, I like to use this too, git checkout B, which automatically creates a new branch. So let's say computer engineering. I'm gonna save this version of it. And then I'm gonna go back. I'm gonna say git branch, just to show you. Okay, I'm gonna check out master now. Git checkout master. And now we're back. All right, so git status. If we look at this, this is my working files, but I didn't actually commit this. So I'm gonna say git commit am fix. And it's standard to say things like in the present tense, like this is what we're doing. So greet hump engineering. Now I'm going to go back to master. And it goes back to computer science because it's showing the state of the directory. And this is being tracked. So git branch. I'm going to get rid of this old branch. I don't want to use computer science anymore. Git branch, delete comp sci. So do people have this state? People who are trying to follow along? You're on the master branch. You made a computer engineering branch, which currently has something different than the computer science branch. So if you say git checkout, comp engineering, so we'll change to engineering. If you say git checkout master, it'll change back to computer science.
Seems pretty scary that you can delete a branch like that easily and lose all of that work.
Well, yeah.
Would it throw an error if it was like more stuff? Would it be like, are you sure you want to delete this branch?
I don't think so. No, I mean, I had previously merged it, so I don't think it will throw an error though if I hadn't merged it. I don't want to try right now, but we can try in a minute.
Yeah.
Yeah, you have to be careful with stuff. It's just like using a command line. You can remove your entire directory, not just your directory, but your entire what do you call it? Disk. Like
RM/RM.
Don't tell me. Yeah, exactly.
Slash.
Did you ever see that video that they did that? Somebody did that to like Toy Story 2. They'd been animating it for like 9 months, and someone ran that command, and they were like watching characters disappear.
That's so sad. I feel so bad.
Yeah, because it can't do it instantly, so it was going through everything, deleting it. Okay, so this is what I want to show you. If you do git checkout B, people asking questions in the chat, are we?
Nope.
Private master branch. Okay.
That was
Let's
a recommendation against how we could avoid deleting it, I think.
Okay. Git checkout. I'm gonna make a new branch, which I'm on, and I'll go back to my file. And I'm gonna say, okay, let's include everyone. CEAS students. Oh, why did I close it? Doesn't matter. So git branch. File again. And then now I'm going to say git checkout master. All right, now I'm going to git merge the computer engineering, right? Oh, git status. I forgot to commit my changes again on CES. Okay, so git checkout CES, git status. Okay, I have this. I'm going to say git commit read CES, git checkout master. And now let's look at git status. All right, everything's clean. It's beautiful. And if I click on this, it goes back to our old thing. And I have these branches. And I know that one of the branches, I changed it to engineering. And another branch, I changed it to CES, right? So first we're going to merge. Is anyone, I know I'm going kind of fast, but they're also kind of basic. So are people still following along? Are people doing this or just watching or?
Do you understand where we are at right now?
Yeah.
My mic was muted. Yeah, all good.
Okay. So I'm going to git merge computer engineering. So this changes it to computer engineering, right? We no longer have that branch. Oh, sorry, we do have that branch, sorry to say. But if I do git log one line, then it will show that computer engineering and the master branch are both ahead right now. Like they're the same thing. This is like that diagram I showed you earlier. In fact, I'm going to go back to it for a second. So if you look at this diagram, these two are the same thing, and they're pointing to this history, but I want you to also notice that git branch, like, you know how I told you that these branches won't show up in each other's history? The git branch CES doesn't show up, doesn't know about that branch yet. So what we're on master, we're gonna merge the CES branch. And this is where we actually get a conflict. So conflict, automatic merge fails, fix conflict. And this is where we get this funny stuff here. And we can see that my master branch was the common ancestor. And these are the two things. So I can choose to delete these files. And I can just keep both of these if I want, or I can just keep one. I'm just gonna keep one and change it to this. This does not really make any sense though, so I changed my mind and I'll just do this. All right, so git status. Oh, I gotta commit my merge. So fix conflicts, I did that. It says here, fix conflicts and run git commit. So I'm gonna run git commit, and I'm actually just gonna give it a message. I don't know what the style I would say to put here, but I'm gonna say keep CES. So I have to say git add the file. So hello.txt. Sorry. Now I think I can do it. Ta-da! So sometimes just like reading what it tells you can get you out of some confusion. So now if I say git status, everything's clean, git branch, I still have these old branches. If I wanted to go back to the computer science engineering, I can keep that. Maybe I decide git branch dot ces delete. And then if we look at git log one line, and I'm actually going to say graph now, and it will show you what happened here. So on one line, over in this left part line, we greeted computer engineering students, and then we had another branch that greeted CES, and then we merged them together and we decided to keep the CES. So that is a very, very basic merge conflict. Obviously they can be more complicated, but if you understand how to fix them, you can get out of a lot of them. So does anyone have questions on that? And I also wanted to make the point that if you make a branch and then you try to merge it back in, it will just accept the most recent changes. It's when you're making two different branches, when you're trying to merge things that have a different history, that it's going to get concerned. It's not going to make it. It's not going to know which one is the correct one, because even though the timestamp, it doesn't really matter. Like if one developer took a branch, right, and made some commits, and another developer made later commits on another branch, but he had the same version of the code, you don't know based on the timestamps which of those is more current, because they're still working off of the same history. Does what I just said make sense?
Yes.
All right. So let's just put this on GitHub now. Let's create a repository. New repository. So I'm just going to create a completely empty repository on GitHub now. And I'm not going to add anything. And when you create a completely empty repository like this, it actually gives you the instructions for how to connect your own. So we initialized it. We didn't add a README. In fact, maybe this should be the README. So let's say it's move mv is a command line command for moving a file. Hello.txt. Let's say call it readme.md. All right, so it shows this as deleted. Git add, I'm going to add the new version of the file, and git commit message rename hello to readme. All right, so we have that. So now we can say git remote add origin, and then this command here, which is the reference to this particular repository in GitHub. And then we can copy this one. Oh, because I didn't call it main. I'm going to call it master. Okay. So now if we refresh this on here, our local repository is on here. And then anyone who wants to clone this, if you git log one line, so this is my history. If you go to code here, if you want to download anything from Git, you can copy this line and then just type git clone, type this line, and then you'll have this exact same thing I have on my computer, this exact same history. Oh, and so you see too in my history, it says on several commits back is computer engineering. It's behind basically at this point. And so now if I want to say git branch delete comp engineering, we're basically just deleting that reference, and if it'll be gone in the history, but the commit's still there. And now I can't check out based on that branch. So git checkout, go back, one EC, do it this way. Go back to the very first IEEE, git checkout. Copy paste it to them. And here is this detached head state that I was talking about. So if I go back to Sublime, I've gone back here. Like different changes, and then let's see what happens. Git status head detached at this thing. So I'm going to say git add hello text, and then git commit hello text message happy Halloween. I don't know. Okay, so it's still saying I'm on a detached head state. And now if we go to log, where this crazy detached head, now if I say git checkout, save this, copy, checkout master, warning, you are leaving one commit behind, not connected to any of your branches.
Okay, that's clever. So they want you to. Okay, so they want you to create a new branch with it. Okay.
So here you can say, you see that the history, that's no longer there. I copied it though, so I'm going to go back to it, check out head. It knows about how we're rolling. So you see this thing is different than this commit and this old thing. So it's not in my history, but it exists there, right? So git checkout branch Halloween. Switch to new branch Halloween. And now I say git checkout master. And I just have it git branch. Oops. Git branch. And so I have this other thing called Halloween. So as you can see, it's not in the history still, but now it's on another branch.
Very cool.
And I can say git merge Halloween back into what I'm in. Merge conflicts. Oh, so so git status. The conflict is that I deleted this in the current thing. So what if I just git add hello back in, git commit. Seems fine. Status. I'm doing great, but I'm ahead of, so it says your branch is ahead of origin master by 2 commits. So I added a bunch of stuff that's not on GitHub, that's all it's saying. But otherwise, it's clean. Git branch, git. And now if we look at the log, it'll show us that our well, Halloween's still in a different, is still at that other place because, but then you see 2 commits back as origin master, that's where GitHub is. So if I wanted to change this, but let me see what the state of, I have 2 files now. So I can say git push, and I'll say, and it'll show up on here, the readme will still be here, but now I have this other file called hello.tech. And it's funny too, if you look at the history of readme, oh, I guess it doesn't have a history besides this. But here's the whole history of master on GitHub. So, if people want to, they could try cloning this. They could try adding their own stuff and pushing it. Make your own branch, try to make a pull request. But this is the basic things I wanted to show you about how these branches work. Does anyone have any questions or anything else that they tried?
If you go to Insights and go to the network, is it going to show all of the graphs for all of the commits? Yep, there we go.
There's like, look at that. There's my Halloween feature that I did. There's this whole history. And also, you notice that I made a branch in here somewhere. Like when I did this computer science, but it's not showing it because there was no, in the history, it doesn't matter. It doesn't care that I made a branch because there was no parallel commits made. But then these branches had something different, so it's worth keeping track of that. So any other questions on GitHub or GitHub in general that you want to ask? Was this useful? Did you learn anything about Git?
did you join the GitHub organization, everyone? Join
Yeah,
the
that's
GitHub organization.
That's important, and make sure you, sign up for GitHub.
Well, we will be going over a lot of this
Join us.
stuff. I mean, and you don't need to know that much about Git to use it. Again, it's just we've basically just gone over the basic commands tonight. I mean, there's a lot more. I was just getting stuck on git stash the other day. I still don't know what it does.
I'll show you what Git stash does.
I'm
Okay.
very curious about git stash because
Alright,
apparently it was one of the only solutions to one of my problems, but I just copied and pasted the command.
Alright, so now I have another file here, goodbye text. I want to say goodbye cruel world. I don't know. You put something in here. Maybe you don't actually want to keep this. Or maybe you do. I don't know. So you say git status. And actually, did anyone clone my repository? Someone want to make a change on there? Let's
I did clone it.
Can you make a change and push it back up?
I could try.
Yes, try and ask us any questions that you have. You write something that you want in the file, whatever it may be, and then just say git commit, and then you can say git push, and that should work.
I'll also try and make a push. Let's see.
Well, I'll also just make an edit on here, because this is another way you can, maybe we want to add some feature workshops. You can actually edit some of these files straight on Git. But now if I say git status, should not be up to date, because I just made a commit on it.
Shoot, this requires a username and password.
Oh, did you?
You gotta have a GitHub account.
I do have a GitHub, just goddamn, I gotta remember where it is.
Oh yeah. Okay, git log, git status.
Oh no.
I feel like this is not actually up to date, so. Well, anyways, say I need to pull more code and I don't want to delete what's currently my thing. I haven't decided if I really want to push this. I don't want to commit it yet, but I don't want to delete it either. You can say git stash, git add. Let's add it to our repository. Oh, goodbye. And then we'll say git stash. And then if you say git dash list, you have this stash here that was never put into your actual repository, but you can, it's saved locally, that you can grab again. And then you can apply it in the future if you want to. So I could pull down code and it won't override this. It won't override whatever changes I did locally. And I say git dash apply.
I got permission denied.
Yeah, I think you actually have to do a pull request because
Pull?
it's my
So git pull?
How do you do a pull request from command line? I know how you do it from a fork on GitHub.
Yeah, I think that maybe I don't know how to do it from command line. I think maybe we should have forked it and then cloned it so you could do it on your own. I should have said that, I'm sorry.
Let's see if there's a way to do it. It's git request dash pull.
if you could put it in the chat. So, James, did I answer your question about stash? It's like a way of stashing your current state without actually committing it to your repository. And you can do it a bunch of times, so you have like a whole list. So like up here I had stash 0, you can have like stash 1, stash 2. And you really might want to do it sometimes when you're like, you want to pull the most recent code, but you're not quite sure if you want to keep what you have, but you're not ready to throw it away.
Right. That's what I should have been doing when editing Fast Clock before, instead of gunking out my entire repository.
So, yeah, there's a lot of commands you can use, like, there's also something called git blame, where you could see who changed what line in the file, and that way you can figure out who introduced something. You can use, there's something called git bisect, which helps you go through your commit history in like a binary search manner to try to find when something broke. And then there's things like git revert allows you to revert a commit, but you have to be careful. Like you can revert the last commit. If you revert an older commit, it may cause conflicts. And if that case, you'll have to do a resolve concept sort of thing. The other thing, if you go to this workshop repository that I created, you can set up, I have a file in here that's actually a bash profile file. You can copy these commands into your bash profile, which on Mac or Linux would be in your user. So if you say, this little tilde takes you to your user directory. I mean, you can have this is my global one, I guess. No, this is not what I wanted to do. Close this. All right. So if I say sublime.bash profile, this opens up my bash profile, and you can do the same thing or create one if you don't have one. And I have some stuff from Mongo and all this stuff in here, but you can copy this into your bash profile, and if you save this file, which I have links to, and you save this script, then it will allow you to do tab completion. This will allow you to change the command prompt and use whatever colors you want. You can change this in here. Another thing you can do is, we did the editor, you can use this line here to set up diff3, which I showed you. And then I just have some more resources here. So I think that's about it. Any final questions?
Let's see how many people we got to join the GitHub org. If we get anyone to join, I will give a tutorial on how to join the GitHub organization. By the way, you should set your membership in the GitHub organization to public. A lot of our members haven't done that, and that means it doesn't show up on your profile. If you want it to show up on your profile, you have to set it to public. So I'm going to share my screen real quick and show you how you go about that. So let's share my screen real fast. Screen 1, go live. Okay, so once you get into the GitHub, did you want to go over GitHub at all? Like what to look for on your profile and everything? Because I can go over all of that if you want. It's like, we're going to give that? Or?
Me?
Do you want to give it, or do you want me to do it?
Go ahead with anything else you want to add.
Okay, so I'm just going to go over GitHub for a hot second, and then I'll show you how to join the org. So basically, when you first log on to GitHub, you're going to be on this, which is your main page, which is on GitHub. So this shows like everyone you follow and what they've been doing. Basically, you can think of this as like your feed if you're on like Twitter or Instagram, except instead of people posting pictures of cats and whatnot, you get to see what everyone else is doing in terms of code. So you can see people, their contributions, the repositories they've created and everything. it's kind of like it's pretty nice. I like to scroll down and see what everyone's been up to. So that's the main page, right? But then what you're really going to want to look at is your profile. So your profile, this is the big thing where you want to basically put everything that you want people to see, right? So when you create a repository with your name, so in order to do that, that's as you can see for me, it's down here. If you create my GitHub username is James Oswald. So if I create a repository named James Oswald and then add a file called readme.md inside of it, actually I think I lost. Here it is. So if you create a file named readme.md in a repository with your name, whatever's in this readme file, which is in Markdown, if you don't know what Markdown is, it's basically just like HTML, except easier. If we actually look inside of it, let's look at the raw. You see it basically just has hello world and James's and these special Markdown format URLs, which basically just tell it where to get the cards generated from. But long story short, you can use these special cards. I think Carolyn's she probably didn't remove the link, so I'm gonna try using hers as an example. So if you click on this, you removed the link. I didn't think you'd do it. I was so annoyed that it linked back to his profile, so I was like, no, I'm getting rid of the links. Normally when you click on these, it links you back to the GitHub README stats.
Yeah, that's fine.
This repository right here. So this repository right here, basically, if all you have to do, you don't even need to like fork the repository or anything, but if you put this on your profile, in your README on your profile, it will generate the card for you using his special API backend that does it. So essentially, you can generate these special cards that show how many stars you have, your total commits, your total pull requests, the issues you've created, and how many things you've contributed to. And then you can also get your top languages as well and mess around with different displays for those and different colors for those. Oh, this is new actually. You can get weekly stats. I have to add that. That's pretty cool. Oh yeah, and they have gradients and everything, so it's like fully customizable. And that's not the only thing you can put on your profile. A lot of people have generated these special SVG images that you can use to display stats on your profile. So this is like fully customizable, and you could even program your own little widget if you wanted to put on here. I haven't looked into that yet, but it's definitely cool. I kind of hate the most used languages because I definitely have not used PHP the most. It just happens to be like the largest amount of stuff because half of my PHP files are HTML and it can't realize that. So that's annoying. But anyway, yeah, so you want a nice, like, strong description as well. I just put in, a little bit about who I am and what I do. And you can also have, like, your little status here. And you can also pin, like, your best programming projects. You can pin up to 6. That's what I have here is, like, what I consider to be some of my greatest projects right here. And then down here, this is what people who are hiring you are going to look for. This is your contributions, the little green squares. This shows how active you've been, basically. So the lighter the square is, the less contributions you've made to repositories that day. And the darker it is, the more you can have contributed. So as you can see, my lighter squares, they're like 1 to 2 contributions. But then on days where I really contribute, it's like 12 to 20 contributions on the dark green days.
Can I just make a comment? So, one, to be clear, these are all just commits. So it's contributions to your own code, including other stuff, right?
Yeah.
And also, this number here includes private repositories, which I noticed that the stats we did at the top doesn't. So all that stuff that I put on GitHub shows up here for me.
Yeah, so actually in your stats cards, you can there's a setting in the stats card to make it so
really?
You can display stuff from private repositories. I think
I tried to do that, but
right now. Great. Works for me. But there's if you actually look at the raw markdown README code, it is, I know it's here, GitHub stats, count private equals true on the
I'm gonna go add that right now.
HTML parameter. So also what you want to do to make sure you get your private commits counted on private repositories is in your settings, you want to set, this is really important, I think it's contributions, this checkbox right here is off by default. If this is off, you will not get credit to contributions in private repositories in your green squares. So you really want to make sure to maximize green squares. You want to make sure you check that, because for me anyway, I have a lot of private repositories, or I did back in the day, like my numerical methods homework, which I have private only because someone found it and they stole my midterm answers. So I had to make that private. And then yeah, so if you want credit for your private contributions, definitely make sure that box is checked. This down here shows like what your primary activity is. I honestly don't like this because personally, everything I do is commit and pull request. But like you can see, 97% of my activity is commits. But for people who are more active, they do a bunch of code review, they create issues, they create pull requests. I primarily, of course, do commits. And then this also shows you like what you've contributed to. So this entire box right here is more for, and I mean, you can edit this. I could turn off the activity overview, and then it wouldn't give me the, the box that shows the activity, but I keep the activity overview on just because it's nice to show what I've actually contributed to, because this is what employers are going to be looking at if you put your GitHub on your resume. So other than that, though, you can see I'm in a few organizations. One of these is a class. Actually, two of these are classes. And then the IEEE is like the big other organization I'm in. But you can join lots of organizations based on what you're interested in. There's a lot that are just open. But organizations basically have just repositories for that organization and code and everything. For us, we have the IEEE website is open source on our GitHub repository. The IEEE website is just this like 3D game, if you haven't seen it. And you walk up to the pillars and they display our web pages. Yeah, so this is all open source on our GitHub. Also, we update this like weekly with the events and everything. But other than that, we have some workshops and everything up here. Our big workshop folder is the Fall 2020 workshops. But basically what you want to do is if you come to this page, which I'm posting in the chat right now, you can join the IEEE Student Branch. And then what you want to do is after you join, you're going to want to click on this people right here. And you're going to want to set yourself to be displayed as public. Because if you're displayed as private, it doesn't show up on your profile. And I mean, if you're in the IEEE, you want the clout of being in the IEEE on your profile, right? So you want to set yourself to public. That's just basic GitHub. Not etiquette, but GitHub hacks, I guess. Yeah, so that's GitHub. Does anyone have any questions about GitHub? You can edit a ton of stuff about your profile and everything. Repositories are just where people put code. You can basically search repositories and everything. Let's say I want to know about some Minecraft repositories. Let's see what kind of Minecraft repositories there. Oh, it tries to search in your own repositories first, which I actually have to, but I'm going to search all of GitHub. You can see, of course, the Minecraft modding scene, Minecraft Forge. I didn't even know Forge was open source. Apparently it is. But you can see that this has like 300 contributors and everything. There's some settings for every repository that everyone should know about. So first you have the sponsor, which is basically just give them money. You basically have to have like a set number of followers to get the sponsor thing to appear. But then the watch makes it so every time an edit happens, you get notified in your feed about the edits or what's going on with the repository if they make announcements or anything. And then star basically just favorites it. That's like the favorite button. And you can actually like get a list of your stars as well. And I mean, a lot of people consider how many stars you have as like the amount of clout that you have, but I try not to worry about that since I only have 1 star. And then finally, fork basically just creates a copy of the repository on your local profile, which you can then mess around with and download. And you can normally what happens if you want to actually edit, like if you want to push changes to a repository that's not your own, like say I had some cool fix I wanted to do on Minecraft Forge. What I would do is I would fork it first. Let's go back. Oh, yeah. So if I for some reason wanted to create like a big edit of it, I would fork it, and then I would, I'll fork it just for the hell of it. I'll just to show off. So I'm gonna fork it to myself, and it's going to take a hot second because it's a very large repository. And then we're gonna go look at my profile, and we're gonna see that in my repositories now, I have Minecraft Forge, and it says forked from Minecraft Forge, right? So if I actually then check on this, it says this branch is even with Minecraft Forge. That basically means that my forged copy is in the exact same state as the the real copy on the Minecraft Forge repository. But if I wanted to actually make edits, I would make edits to my fork, and then I would click this pull request button, and then I could say, okay, so I haven't actually made any changes, but let's say I did make a change. Let's say I'm going to create a new file, hello.txt. This is a change. I'm gonna commit a new file here. You can commit things really easily like that. So now see it says I'm one commit ahead because I just added that file. I'm gonna click pull request to make the pull request. This is what we were talking about before. And long story short, I can say, okay, I'd like to make this pull request. This is showing that the head repository, which is basically the repository that has the changes made to it, which is, because it's ahead of the base repository, which is the Minecraft Forge, like the official repository, and then this is my fork. So then basically I could, if I really wanted to, and it shows the changes down here, I could create a pull request, and the pull request would be me saying, hey, I'd like to merge this into your code base. Of course, they would laugh at me and be like, why have you created a file named hello.txt and added it to the root? That's completely useless, and they would deny this pull request and just delete it. But if instead I was making like a serious bug fix, I would be editing like Java files and whatnot here, and then I would create the pull request, and then they would potentially say, oh, okay, these are good changes, or no, you need to do this, and they may or may not accept it then. But this, I'm going to just completely discard this, and yeah, that's just a quick little intro on how you can, edit fork repositories and everything. So that's my brief overview of GitHub. My bad if it went on a bit too long. I'll hand it back over to Carolyn if she has anything else to say, and then if not, I will wrap up.
That was great. Thank you, James.
Yeah. No, thank you for the Git section of this. It was very helpful. So, do you have anything else you want to say, Carolyn, or can I wrap it up?
I'm good. Wrap up. Okay.
So we are going to tonight, right after this meeting, the e-board is going to convene, and we're going to vote on JBoard and dboard positions, and hopefully we'll have your results to you by tomorrow on what positions people are getting. Yeah, that's basically it. I mean, is there anything anyone wanted to ask? Or am I forgetting anything? I mean, I did go over GitHub pretty fast and didn't ask if anyone had any questions. Any GitHub questions? No? Okay, excellent. In that case, yeah, I guess workshop over. Thanks for coming, everyone. This Friday, we'll be having another personal project development night. And next week, JBoard and dboard members who got accepted, we're having our monthly officers meeting. Yeah, so more info on that if you get accepted or you applied or you're curious. Yeah, so thank you, everyone. Bye-bye.
Thanks, guys.
Thank you for coming. Bye.